Okay, so for the start of section 4.2, we're going to be talking about what's called a least squares regression line, or what you're going to hear me call a line of best fit. So once we have found a correlation coefficient, and so we've said there is a linear correlation here or there's not, we then want to figure out what is that line, okay? Because we would actually be able to get some information using that line. So the first thing we've got here is we're back to that square footage with the houses, okay, type of thing. And so the concept here is we want to rough in a line, okay? But we don't just want to like eyeball the line. We want to have a really good precision for what's going on here. So what we have here is they give two examples here. One is a negative. Obviously, we know that this is already positively linearly associated. So this one is an N. But what we want to have here is the distance that each data point is away from the line is made as small as possible, okay? So making small tweaks to the line as far as how steep it is, how shallow it is, how far up it is in the graph or down it is in the graph will create, and by calculating these distances and squaring them, kind of the same way that we saw when we did standard deviation stuff, we want to make that total as small as is possible, okay, when we do this. And so this will allow us to then do some stuff like making predictions and things like that. So when you're given ordered pairs and we have a sample mean X and a sample mean Y, and we've got standard deviations S of X and S of Y, and we have a correlation coefficient, then we can find this equation, which is Y hat, it has this little hat symbol on it that's called Y hat, is B sub 0 plus B1X, okay? B1 is your slope, okay? So B1 is your slope, and B sub 0 is your y-intercept, okay? Now, what we're actually going to see here, okay, and I'm fixing to associate how this is done and show you kind of where this is at. When we're processing, we've got to just kind of connect and find out our calculator, because we're going to do this all on calculator. We're going to allow our calculator to tell us what the slope and this intercept are, okay, or what their values are. Now, we will now be able to make predictions where if we give it an X value, we can output a Y value. We can also put in a Y value and get back an X value if needed. Those are less common, but they can still happen. So now what I want you to understand is we have, and the way that this book presented this, B1 is the slope. And what you need to know is that the slope is right in front of the X value, okay? So the slope is always going to be associated right in front of the X variable, okay? And then B naught is your y-intercept. Now, when we work with a calculator, the format that we're going to see come up is this AX plus B, okay? Just the slope from X, and B is my y-intercept, okay? And so we do have that we've got to kind of watch and make sure that we're putting the slope in front of the X value and the y-intercept